So next up, we're going to take a look at solving exponential equations. Example 1. A laboratory received a shipment of 200 grams of radioactive radon, and 16 days later, 12.5 grams of the radon remained. Calculate the half-life of radon. So half-life is the time that is required for an amount or mass to decay half its initial value. So for example, if you had a half-life of 3 days and you started with 100 grams of a substance, then in 3 days you'd have 50 grams. 3 days later you'd have 25, and 3 days later you have 12.5, and so on. So the half-life formula is m of t, where m represents the mass, equals a 1/2 t divided by h, where again m represents the mass at time t, a represents the initial amount or the initial mass, 1/2 is your decay factor, t is the time we're looking for, and h is what we call the half-life, how long it takes to decay to half its initial value. Using that formula, we have that m of t is equal to 200, its initial value, times 1/2 t divided by h. And we know that 16 days later, there's 12.5 grams left of the radioactive material. So we have 12.5 equals 200 times 1/2 to the exponent of 16 over h, where h is the half-life. So our goal is to isolate for the variable h. The first step when solving exponential equations is to get one term and one factor on each side if possible. So for this example, we can divide both sides by 200, and we have that 0.0625 is equal to 1/2 to the exponent of 16 divided by h. Now that we have one term and one factor on each side, we can convert to a logarithm. So this is log of base 1/2, 0.0625 equals the exponent 16 over h. Flipping both sides of the equation, we get h over 16 is equal to 1 over the log of 1/2 of 0.0625, which tells us that h is equal to 16 divided by log of 1/2 of 0.0625. And all I did here was multiply both sides by 16. Using our calculators, for those who only have base 10, to evaluate h, we take 16 and we divide it by the log of 0.0625 divided by the log of 0.5. And doing that should give us an exact value of h equals 4. Therefore, the half-life for this isotope of radon is 4 days. So again, quickly going through the steps. Sub in your variables, try to get one factor on each side and one term. And then to isolate for h, we're going to need to rewrite as a logarithm. Example 2. An investment of $5,000 grows at a rate of 4.8% per year compounded monthly. How long will it take for the investment to be worth $6,500? And recall that the formula for a compound interest is a equals p 1 plus I to the exponent of n. So first of all, let's identify our variables. We have our future amount, which is 6,500. We have our principal or initial amount, which is 5,000. We have an interest rate of 4.8% per year, and since it's compounded monthly, we're going to have to take that interest rate and divide it by 12. And that'll give us a monthly interest rate of 0.4% per month. And n represents the number of months. And how do you know what it represents? It's based upon your compounding period. So if it says monthly, then our n value is in terms of months. Subbing these values in, you get 6,500 is equal to 5,000 times 1.004 to the exponent of n. Next, we're going to divide both sides by 5,000, and that gives us exactly 1.3. And now that we have one factor and one term on each side, all we need to do is convert to a logarithm. So we get that n is equal to the log of base 1.004 of 1.3. So once again, if you have a calculator with only base 10, this would be the log of 1.3 divided by the log of 1.004. And this will be the number of months. So n is going to equal approximately 65.72 months. So now we can conclude and say therefore it'll take about 65 months, or we can convert that to years, whatever we need to do. Alright, next we're going to look at solving other types of exponential equations. So let's solve 2 to the exponent of x plus 2 minus 2 to the exponent of x equals 24. Again, we need to get one term on each side. So how do we deal with this here? If you use your exponent rules, you get that 2 to the exponent of x times 2 to the exponent of 2 is equivalent to 2 to the exponent of x plus 2, using your product rule. So again, recall our product rule, 2 to the x, 2 to the 2 is equal to 2 to the x plus 2. So why do we do this? We have a common factor of 2 to the exponent of x. So we get 2 to the exponent of x. 2 squared minus 1 equals 24. And 2 to the exponent of 2 squared minus 1 is equal to 3. So we get 3. 2 to the exponent of x equals 24. And 2 to the exponent of x is equal to 8. Notice now we have an expression that we can solve for by converting it into a logarithm. So we get x is equal to log base 2 of 8. And this one we don't need a calculator for. 2 to the exponent of 3 is 8, so x is equal to 3. And again, you can verify your work using the equation. So if I were to verify, if I take the left side, I get 2 to the exponent of 3 plus 2 minus 2 cubed, which is 2 to the exponent of 5 minus 2 cubed, which is equal to 32 minus 8, which is equal to 24. And that equals the right side, so we know that x equals 3 is a solution to this equation. This one, since the bases are not the same, and we only have one term on each side, I would recommend taking the log of both sides. So we're going to take the log of 2 to the exponent of x minus 1 equals the log of 3 to the exponent of x minus 1. Then I would recommend you use the power rule for logarithms. That means I could bring the exponent to the front, so I get x plus 1 times log of 2 is equal to x minus 1 of log of 3. We can now expand the logarithm into each set of brackets. So I get x log of 2 plus log of 2 is equal to x log of 3 minus log 3. Next step is to move all the x terms to one side and all the numbers to the other. So I have x log 2 minus x log of 3 is equal to negative log 3 minus the log of 2. Common factor of an x from the left side leaves me with a log of 2 minus a log of 3. And finally, the last step is to divide both sides by log of 2 minus log of 3, so that you can isolate for x. x equals minus log 3 minus log 2 all over the log of 2 minus the log of 3. That would be your exact answer, and if you want, you can use your calculator, and you should get an approximate answer of 4.42. Again, you can verify by subbing 4.42 back into the equation, and you should get that the left side is equal to the right side. Questions for you to try? Good luck.